answer them. Cool. Can you see that? Maybe? Yes. No. Yes. I hope so. Cool. So I'm Ben. I'm head of engineering at Dataform. I think I've spoken to some of you before, but it's nice to meet the rest of you that I haven't met yet. We're going to be talking about CI/CD for Dataform projects. And if you have any questions or anything, feel free to jump in and just ask. But otherwise, you can always email me at ben@dataform.co. Cool. So what's the problem we want to solve? Concretely, the problem we want to solve for Dataform projects is we want to make sure that all code changes that you make and get pushed into the master branch compile correctly, and maybe even test correctly or run correctly. And we'll talk about some of those bits and pieces as we go. So what is CI/CD? There's lots of stuff written about this that's sort of high level, but in practice, what it actually means, to me at least, is for on every git commit or git push or opening a pull request, typically to the master branch in Git, we want to automatically run some tests, where test is sort of an abstract thing. We'll get into the concrete details in a minute. And assuming they pass, then deploy the change. So we're interested in that running the tests part, because tools like GitHub and GitLab take care of much of the rest of the thing. Cool. So how do you configure this? Well, it depends on your tool of choice, your continuous integration tool of choice. I'm going to talk about GitHub Actions, and I'll run through a demo of how to set that up for a Dataform project, because I think most Dataform users use GitHub. That said, I suspect GitLab is pretty similar, if not the same. And configuration is pretty similar in other tools like Google Cloud Build, which happens to be what we use. I'm going to document all of this in the Dataform doc sites with examples of common tools after this session. So if you do have any questions about that, you should be able to find, I guess, good examples of how to configure this for your continuous integration tool there. All right, so in GitHub, you typically set up CI using GitHub Actions. So I really like 1,000-foot or 10,000-foot view of what GitHub Actions are. They are automated workflows that you configure using YAML. They contain a bunch of execution steps that you configure. They can be more or less arbitrary commands that you want to run. You can run scripts that you have in your Git repository. You can run so-called actions defined, published by other GitHub repos, or even that Git repository itself, or arbitrary Docker images, which is a very common pattern for CI tools. We actually publish a Docker image containing the Dataform CLI tool, and that's the Docker image that we'll be using in our GitHub action. And we publish this on every version, like Dataform version bump at this point. Cool. So actually, it's super simple to set this up in GitHub. I hadn't done it before today because we don't actually use GitHub Actions internally, and it's actually really, really simple. So all you need is a workflow YAML file. It has to go in this .github/workflows directory, and then you can give it any name, and it has to be a YAML file. And I'm going to quickly talk through this before I show you it working in practice. So very simply, it has a name. That's fine. That's just for GitHub display purposes. Then we tell GitHub what events to run this workflow on. So anything that gets pushed to master, we typically want to run CI checks. We want to check that the master branch still compiles. And usually also any pull request that is requesting to merge to master, you also want to run these checks. That said, this is all configurable, right? So this is just what I assume would be the default setup. And then this job section lists out what we actually want to do, right? So it has a name, it's compile. It doesn't really matter very much. We tell GitHub what it runs on. I've just chosen Ubuntu because that's more than enough to run the simple stuff that we need to run. And then we tell GitHub the steps that it needs to run through. So firstly, you need to check out the code. That's literally the equivalent of a git checkout command, just checking out a copy of that repository into the current workspace. That's this first step. Then secondly, we're going to need to install project dependencies. So if you use Dataform Web, you're probably pretty familiar with the package.json file that you have to update the Dataform core dependency version every so often. And in Dataform Web, we actually take care for you of installing the dependencies underneath the project on your behalf. But because obviously GitHub doesn't know how to do that, you need to install project dependencies sort of explicitly here. And we are using as it says, this uses Docker, Dataform Co, Dataform, and the latest version of this Docker image. So we're using that Docker image, and then we just run the install command. So this would be equivalent to, on the command line, running Dataform install, which is more or less equivalent to, if you know about npm, it's running npm install. Then the last stage is just to run the Dataform compile command to check that everything compiles. And it's, again, very similar to the above example, using the same Docker image. We just run a different command, the compile. Again, this is equivalent to running Dataform compile on the command line. And if compilation fails for some reason, the command will fail, and then this whole workflow will fail, and GitHub will tell us. So one sidebar here that I'm going to show you as we go, because not everybody's like super familiar with how GitHub works. If you are setting up CI/CD checks, I would strongly recommend you to turn on branch protection for your master branch in GitHub, simply because like this then prevents you from being able to accidentally merge something that doesn't pass the checks that you've put time into adding. Cool. And now let's do the demo. Sorry, people keep pinging me on Slack. This is very distracting. Cool. Can you all see that? That's Dataform?
Yep.
Thank you. So this is a very simple example project that I've set up before. It has a single SQLX file. Nothing particularly interesting or complicated about this project. I will quickly show you in the settings. We are connected to a GitHub project, GitHub repository, sorry, and I happen to have turned on pull requests for all changes just because that makes the demo a little bit simpler. Cool. Let's go back to the modeling, to the file. And you can see this is the GitHub repo in question. Let's quickly refresh. And yeah, it has the exact same stuff as we see in Dataform. Cool. So what do we do first? I just said that we needed to set up the new workflow file. So we can do that pretty simply. We can do that straight in GitHub, actually. This is pretty cool. We can just do .github, as I said, workflows. Oh, I got to check my notes. Yeah, workflows. And we can call it anything. Let's call it different YAML. I'm literally going to copy paste that stuff in that I showed you before, because I know that works. And I'm going to say, cool. So that's in there now. And this means that from here on in, GitHub is going to pay attention to the events that we defined in that YAML file. These events like on pushes to the master branch or pull requests to the master branch. And it's going to run this check or this workflow on those events. We can actually see it will have run this workflow on this commit. We can go into Actions here, and we can see this is the commit that I just made, and it's actually running the thing right now. And here are the different steps that we kind of defined earlier, right? So it has to pull the Docker image here, but then it's checking out the code. That's not very simple, not very interesting, but it's the equivalent of git checkout. This is running the Dataform install command. You can see project dependencies successfully installed. And then running Dataform compile. And you can see we did compile one action, and there's that Dataform.example1 table. Cool. So far, so good. And everything passed here, big green tick. Right. So I'd promised to show you how to set up branch protection because I think it's a good idea in this case. So we can just open the settings tab in GitHub, click branches, add a branch protection rule. We're going to want to do it on master. I want to require pull request reviews. We want to require, this is the important thing, this require status checks to pass before merging. So, I mean, it does exactly what it says on the tin. Once I've ticked this compile thing, this was the workflow name, if you remember from earlier, I called that workflow compile. This just means that GitHub will not let you merge something until it passes this status check. And then we just create. I'm not ticking the included administrators in this circumstance because I'm the only person who has access to this project and I am an administrator. So I'm going to have to push past these checks just for the sake of the demo. But it's just my recommendation that you set up these things. Password, cool, that's set up now. Right, now we are living in a world that has this workflow and I just want to prove to you that it does what it says, or does what I've said it should do. So let's say we come back into our Dataform project and we're going to intentionally break compilation. So I'm going to ref non-existent table. And very quickly we should see, yeah, okay, Dataform itself is complaining this doesn't compile, but still I'm going to commit it. I'm going to break that compilation, commit that. Ooh, interesting. Oh yes, because I've made that workflow. Pull that. Ooh. Okay, and now I can push it to GitHub. They said never do live demos. Okay, cool. Open pull request. So we can see this is the change I made. That's fine. We're going to create a pull request, call it whatever, it doesn't really matter. And we can see this is the check that I configured earlier. So wait a couple of seconds. So firstly, you can see merging is blocked, both because it hasn't been approved, but also because this hasn't passed yet. We can click details on this check, or indeed click the checks tab up here. We just click details and we can see what's going to happen. So it's doing all the things it did before. Cool, now it's running Git from compile, and indeed, compilation failed. Oh, sorry, let me show that a bit more clearly to you. It's complaining there's a missing dependency, as we saw. Right, cool, and if we go back to the PR, it's failed, and merging is blocked. Cool, let's undo that, and we can show you that then everything works nicely. Again, push it again. Cool, let me refresh this. In fact, I didn't even need to. GitHub did it for me. It's going to quickly run the checks again. And cool, we're back to normal and everything will go green. And all checks are passed. And I can merge this because I'm an administrator. Like I said, you can turn that off if you want to. Cool. So that's CI/CD in a nutshell, the simplest form you can set up using just checking compilation. But I wanted to show you that it is possible to set up something a bit more complicated if you're interested in that. So for example, you might want to run your unit tests if you have any, or just in fact execute a whole Dataform run on every commit if you want, like on every pull request to master. Let's say you wanted to make sure that end-to-end a run worked. You can make that happen. So the tricky thing here is, so I'm going to show you, this is a second project that I've set up earlier just to show you this example. The tricky thing here is, of course, that when you want to run unit tests or start a run, Dataform needs some credentials against the target warehouse to be able to do so. If you've ever used the Dataform CLI, like on the command line, you may have seen this sort of pattern before, .df credentials.json. That's where we store credentials if you use the CLI. But we obviously don't want to check in unencrypted credentials into a Git repository. That's just like super unsafe. Don't ever do it. And in fact, so GitHub's suggestion for what you should do in this circumstance is that you check in an encrypted version of those credentials. And I'll show you very quickly how that works. And you then, as part of your workflow, decrypt them, and then you can go and use them as you wish. So how does this work? GitHub just recommend that you basically use, or run a couple of commands to encrypt a file. You have a passphrase which like controls encryption and decryption of that file. You can then store that passphrase inside the secrets section of a GitHub repo, and I've just called it credentials GPG passphrase. And then you can use this secret inside the workflow to decrypt those credentials, and then you can just, then the file will be there and you can just use them. So I'll show you the workflow, which will hopefully make this clearer. So again, .github workflows, open up the YAML file. So this looks pretty similar to what we saw before. Same events, everything up to here is the same. We're installing npm dependencies, so that's fine. The interesting bit that's extra is here. So we run this decrypt credentials shell script, and I can actually, very quickly show you that. It's very simple. It's literally just running a GPG decrypt using this as the passphrase, this credentials GPG passphrase as the passphrase to do the decryption. It outputs the original file that we want it to, unencrypted, and it takes the encrypted input. So this will, we pass that credentials GPG passphrase using this sort of magical GitHub Actions incantation, which just tells GitHub Actions to pass through this secret that I showed you earlier. And then the shell script runs, again, very simple command. It will then output that unencrypted credentials file. Then we can just run Dataform unit tests, or whatever the command is, and everything will work as we expect it to. So in fact, just a quick demo of this. If we, I don't know, let's say I add a comment to here. This is the project that's this is the project that's attached to that GitHub repo that I just showed you with the secret. I'm going to commit it, that thing. I'm just going to quickly push this directly to master because that's fine. I haven't decided to set up branch protection for this thing. And we should see inside here, the Actions tab that I showed you earlier, we can see that it is running similar to what we saw before. It's going to pull the Docker image, checking out the code, installing npm dependencies. It'll decrypt the credentials as I just showed you, and then it's running that as you would in the Dataform UI or using Dataform CLI. So it went and created that single data set. But you could imagine a much more complicated run if you want to. Cool. So I think that's everything. Yep. Do you have any questions?
Hi, Ben. Thanks for that. We were chatting, I think, in the week or previous week. I've got a question on GitHub Actions. The compute, is that is GitHub Actions the compute that you use on Ubuntu? Is that something that you pay for as part of your enterprise license, or how does that work?
I don't actually know the pricing of GitHub Actions. Again, like I said, we don't use them internally. I think you get a free tier up to a certain amount of maybe runs or like compute minutes per month, but I'm not sure of the details.
Okay, but it was something. It looked like you just whizzed right past that without them.
Yeah, and in this
asking.
circumstance, like I'm definitely using free tier. This is just under my personal account. There's definitely no billing attached to that.
Okay, cool. Thanks. That looked cool. I'll definitely. I was hoping to figure out exactly what you've done, so it looks like I don't have to. I'm just going to look at this again. Thanks. So thanks.
Cool.
I'll ask a question. If you had an assertion in your graph and you had Dataform run as one of these tasks that was running as part of a GitHub action, and the assertion failed, and you'd set up this to block merging, would it do exactly that?
Yeah, it would do exactly that. So the assertion would fail, and the Dataform CLI would exit with like a failure exit code. GitHub will see that, and then the check will fail, and you won't be able to merge the PR, etc.
Cool.
Oh, by then, wouldn't you have published the bad data already? Or are you suggesting doing that in a development environment separately?
Yeah, I would suggest doing that exactly. So like whether you set that up by sort of using environments inside Dataform Web so that your production data is always separate from anything you might run inside the GitHub action, or there are certain flags you can pass to the Dataform CLI to force it to run your graph in maybe with a different schema suffix or a different warehouse or whatever, different database. But yeah, I would suggest that you probably run this as you do like a development data set inside Dataform Web today.
Alternatively, I suppose I could do a dry run and skip the assertions.
You can't, I mean, you could skip. So a dry run do you mean the dry run flag in Dataform CLI?
Yeah.
So that, just for clarity's sake, that dry run doesn't run anything, right? Like it just computes the set of actions that will run. Cool. Yeah, but yeah, you can absolutely do that.
Well, but I assume a dry run would still throw errors if there's compile errors and stuff like that.
That's right.
Yeah, cool.
It won't throw if you have like SQL errors, which I think is something we kind of keep coming back to and discussing. I think that'd be a really interesting case for CI/CD, where you actually want to check that someone's not broken the SQL. I think it's far more likely that's an error you make. If there's a compilation error, then we make it quite clear to you before you push. But I think with SQL errors, it's much harder to tell. Unfortunately, right now, I think the only way to detect that is to run your entire pipeline, particularly if you're using operations. But yeah, we do keep coming back to this point. There might be something clever we can do, like having an option to always create views, even if there are tables or incremental tables, so we can just validate that all of the SQL actually is okay. And then that would basically be a Dataform run, but one that should be very quick and shouldn't cost you any money.
Yeah, because I was just reviewing your incremental pipeline, and for a full refresh, it would cost us a terabyte of money. And while an incremental refresh is like less than cents. So, we at LiveUp, we do not use a copy of the warehouse in a separate data set or anything like that, just because it would cost too much to maintain that. It's much cheaper and easier just to fix errors as they arise. And I would be very interested in doing CI, but to validate specifically those pesky errors in incremental tables where you might have, say, when incremental clause has a where, but there's already where in the other clause. Those types of things aren't so easy to catch just looking at the query. So, I mean, I understand we don't have that at Dataform now, but it would be a huge boom for us.
Cool.
I have a quick question. So I haven't used the CLI really at all. And one of the things that I've kind of looked through the available commands, and one of the things that I think might eventually be helpful is that if we could output the compiled SQL itself. I think there was actually a discussion about this earlier this morning in the Slack channel. But one of the reasons that we would really like to be able to do that is we have started work on some linting and formatting for Jinja templated SQL or SQLX type files, and it would be nice if we could rely on Dataform to kind of generate those files. I don't think I'm not sure if CI/CD is really the right answer for checking the formatting and linting on those, or if hooks might be a better, pre-commit hooks might be a better approach. But that's really, we're to the point now where we'd like to really start to dig into consistency in style.
Sure.
And unfortunately, our formatting preferences are a little bit different than the built-in formatter. So is that something that that might be available in the future, or is that a direction we should go, or is CI/CD really not the answer there?
So I think you're probably right in thinking that CI/CD isn't. I mean, it could be the answer there. I think it's sort of orthogonal to answering the question about outputting the compiled SQL. You can actually output compiled SQL with the CLI. It may not be in the form, in the most helpful form for you to consume. It sort of depends on what tool set you want to wrap around that. Assuming you can read JSON, you can actually consume the compiled SQL. If you just run Dataform compile, I think --JSON, you'll get the full compiled output of all that SQL, and then you could presumably run that against whatever linter that you want to run, and that could be part of CI, sure.
Okay. Great. All right. Thanks.
Yep.
One more question about what you said about the dry runs. What exactly does Dataform do when I tell it to do a dry run? Because I half expected it to send my queries to BigQuery, my warehouse, with the dry run flag set, but that would throw SQL errors.
So yeah, I think there's probably a bit of overloading between the term BigQuery dry run and then Dataform dry run, because obviously other warehouses don't really have a dry run option. What concretely happens is we're taking the compiled SQL and then turning that into the final SQL that will run as part of a run. And to do so, we need to go and ask your warehouse what tables exist, maybe what their schemas are, etc. And then both the combination of that warehouse state, that's what we call it, that warehouse state, plus the compiled graph, you get output the final execution graph, the final SQL that will actually run. And so a dry run is really just there so that you can have a look at that final SQL before it runs. But yeah, it doesn't go and, for example, in BigQuery, run the dry run command. For what it's worth, when you're inside Dataform Web and stuff on the right-hand side is saying everything is compiling, but the SQL isn't validating, it is using a BigQuery dry run in that circumstance.
That's what I imagine. Is that anything I can do in such a CI flow as you demonstrated to run the built queries, the compiled queries against BigQuery using a dry run rather than running the entire pipeline?
I mean, so this comes back to what Lewis was talking about a minute ago. There's something interesting we could do there. That said, there's nothing stopping you setting this up yourself if you want to. Similarly to my answer to Will, if you want to go and read through the SQL that's output as part of that execution graph and dry run that stuff against BigQuery, you absolutely could write that code.
And is that why when you compare that, when you compile that SQL query during the Dataform's dry run, is it output somewhere?
Yeah, again, if you pass that --JSON flag,
Cool.
You'll get the exact same.
Cool, awesome.
So I think the challenge with the situation is if you have if you have a dependency chain, maybe a table which is then read called A, which is read by another table called table B. If you make a change across both of those tables, which kind of need to be made together, if you just kind of validate the individual queries on a per query basis, they're probably going to blow up and tell you that these aren't valid. And I think that's the really challenging problem to solve here. Like, how do you actually validate an entire Dataform graph is a quite challenging problem, because you kind of need to model these changes together. And there's a few things we've kind of discussed doing, like we could inline every query, every dependent table's query into like one massive query, but then you start to hit limits of what BigQuery will let you do. I think, yes, I know I mentioned it briefly, but having an option to actually do a run where we create all tables as views instead, and you could do that in some kind of like, I don't know, temporary CI/CD schema is maybe one way. Snowflake has this idea of like table copies, which Dan found this morning, which would allow you to kind of make a kind of quick clone of your whole stack, run some incremental changes, and then discard it. But yeah, doing this actually in a correct way is really challenging. And then you've got the extra complication of, I don't know if you guys use many of them, but operations files are kind of, we don't know how they're going to behave, and we can't reason about them particularly strictly. So yeah, these are the challenges. But I think as a signal, you could definitely easily validate an individual queries. It's just that you've got to accept that large refactorings or changes between tables, that's going to fail.
Yeah, that makes a lot of sense. Thank you.
Yeah, the other thing to add to Lewis's list of possible solutions, the one that I favor, but I'm not sure if he does, is like actually producing a copy of all your Dataform tables just with like empty data sets. So everything that's a view is a view, everything that's a table is a table, but just like with no actual rows in there. Cool. Any other questions?
Maybe just a suggestion. Another way that could work is to publish the tables using a limit 0, because then you'd publish the schemas and then there would be no data. You wouldn't be charged for that, but it still allows BigQuery to validate the changes. That would have to be done in a separate environment, but at the least, I wouldn't be scanning all my tables and recreating all my tables at publish time. Yeah,
I think that model is quite nice. This is what I was just describing. I think that's quite clean and nice model. But yeah, we think about this a lot, and I'm not sure we've come up with like a nice answer. I think the biggest problem, as Lewis said, is about operations. Because you can just run arbitrary SQL, it's sort of hard for us to reason about what you can do there. So if you can avoid operations, don't run operations.
Yeah, thank you.
Cool. Will, were you just about to ask a question? I think you unmuted, but I don't know.
Oh no, I was just gonna say that I really appreciated this presentation. It's very timely for what we're trying to do, and definitely wanted to continue, kind of this format. I think this has been really helpful for us.
Cool. Your feedback goes straight to Josie because she's nice.
Yeah, and if you have any suggestions of other features or topics that you'd like to cover in office hours, again, just let us know on Slack or ping us on email.
All right, will do. Thanks.
Cool.
Well, thank you everyone for listening. As always, if you have any questions, ping us on Slack. You can email me, you can email the team. We've got intercom. Lots and lots of different communication channels. Thank you for listening.
Thank you. Bye.
Bye-bye.
Thanks, guys.
Thanks, everyone.